Um, Hope you guys can hear me. Cool. So if we take a poll today here on what the best programming language is, it would probably come up as Go, and it can be, there's a high chance it's unanimous also. But if we take another poll about the best editor which you can use, you know, there can probably be a large debate and maybe some punches may be thrown. So that's the state of our opinions about our editors, right? So, but it's a integral part of whatever we do as a engineer. So it's close to our heart. But have you ever wondered, like when you press Control Space, or when you hover over a particular symbol, how does the documentation appear? Or when you Control Space, how does a list of things appear? Right? So I was curious about it, and I think I've got some answers today. So that's what this talk is about. So a little bit about me. So I am a senior software engineer at Hasura. So Hasura is basically a data layer for your application or your product. It basically stitches all your data sources and gives you a unified API. So it's a pretty cool product. If you want to learn more about it, talk to me afterwards. And Hasura has a declarative configuration. And I work closely with the developer experience team at Hasura, and we are trying to sort of improve that experience of writing the configuration, the declarative configuration. So that's how I started experimenting with how these editors work, what happens under the hood, things like that. So that's about me. Then let's take a stroll down the history lane. So think about how we would have used, or we use, a new programming language with our favorite editor. Let's say, for example, you're going to try out a programming language Y, and you use editor A, right? So normally what you will do is you will download, or you find a plugin for that particular programming language, which is supported in your editor, download it and use it, right? And the same happens for a different editor also. That's for fun. Take Emacs and Vim, for example. Let's say you want to, write Python in Emacs. You probably will have a Python plugin, right, for Emacs. And for Vim, the state will be same, right? You will have a Vim plugin, which helps you write, Python in Vim, right? But the problems they solve are very similar or the same, right? And we probably will have better implementations of the same thing in different ecosystems. Maybe the Emacs plugin is good at autocorrection or autocompletes, and Vim plugin is better at something else, right? But we are wasting resources there, right? Can we sort of find a solution for that particular problem? So this problem has been around like for a while, and it'll look something like this, right? You'll have an editor X, and you'll have some plugins for a language, or the languages that you're writing, and for the same editor Y, you'll have the same thing, right? So what is that solution? We probably would have guessed something like this, right? Like for a language A, you can have something which both editors can speak to, right? Editor X can speak to that component and get whatever language features or whatever editor features it needs for that particular language, right? So this can be the solution. And the team at Microsoft actually formalized it in the form of a protocol called the Language Server Protocol. And all the modern editors that we use today support this protocol, and that is how we get all are editor features which are amazing, right? For example, your hover, your autocompletes, your refactors, things like that. Now, like, what is the language server protocol? So a language server protocol is a simple client server model, right? Where the server implements this protocol, and the client will be our editors, our Vims, our Vmax, our VS Codes, things like that. So whenever an editor wants to do something, like for example, autocomplete, it sends out a request to the language server, and it replies back with whatever it asks for, or whatever the editor asks for, right? And the protocol is also very simple. It uses JSON RPC under the hood. So we can look at how these messages will look in detail, after a couple of slides. But and the protocol doesn't specify any medium of communication. So this communication can happen via standard input, standard output, inter-process communication, over the network, stuff like that. So that's how. So that's why your cloud IDs, your local VS Code systems, things like that can use the same system, but over different communication mediums, right? So that is what the LSP protocol and the interactions it has with the different editors looks, from 10,000 feet. So so what's the magic? How does it all happen? So this is an example of a JSON RPC request that VS Code sends to your language server. Like for example, this is a request of type text document hover, which is the request type that gets sent over when you hover over any of your symbols. Like for example, if you have a function, let's say we are using a standard library function, right? And when you hover over that, you get a documentation, pane, right? So that comes from this particular request. So VS Code sends in this request to the server, and the server will return back whatever documentation it has about that particular symbol. So so what I wanted to show today was Go, please. The Go language server. Yeah, come on. So what I wanted to show you was a walkthrough of Go, please. So Go, please is the Go language server. So that is what powers whatever Go language features that you use in your favorite editors, right? It is implemented in Go, and it is under Xtools, I think, the repository. But it's a bit complex and involved. So I wanted to show you something which is simple enough, but it is used every day, by a lot of people. So I didn't want to sort of show you some toy program and leave you with it, but a real world system that you could refer to after the talk as well. So what we're going to look at today is the VS Code YAML language server. So there is a problem there. So both these systems are written in TypeScript, but we can just refer that for the sake of it, right? So here, what I have, don't mind the red squigglies and all. It's because I don't have some dependencies not installed, so that's where the red squigglies come in. So don't worry about that. So what we have here is two things. One is the VS Code YAML extension, the VS Code extension that you install in VS Code, and the language server itself, right? So so what I'm going to do is I'm going to quickly launch this extension. It usually takes a second. Right. So So this is an extension which is running in a VS Code window. And here, what you see over here in the terminal window is the request that this particular editor sends when it needs something, right? So, for example, let's do a hover and see if it registers that, right? So, okay, for some reason it's not firing, maybe because of my red squigglies, it's not updated or something, but you get the idea, right? So here you can see there is some request that is sending for a code action and some parameters, and it is going to get some response from the server with whatever. In this case the result is empty, but in a real world situation this result will have something in it. So that's the basic idea of how this works. And now let's go back to the slides. So this, I didn't want to go into too much of detail, but these language servers will have its own problems, like interesting problems as they're on. Like for example, if we think about the compiler that these language servers uses, it should have some specific properties. Like for example, in your normal Go compiler, it can stop compiling at the place where it finds the first error. Like for example, you didn't define your function correctly, you had some syntax error, things like that. The Go compiler can stop there, right? But if you're editing in your editor, the compilation has to go on, even if there are like a couple of errors, right? So then only you can get that rich completion, rich assistance in writing your code, right? So the parser that these language servers use should have these properties, right? And it should also preserve the original content that it show in the editor, right? Each space, each tab, each exclamation mark, or whatever symbol which might not be a valid token in your programming language will also have to be tracked, right? So basically what you need is a looseless syntax tree. Looseless meaning we don't lose any symbols that you provided to the parser, right? Because we need that information to reconstruct the edit, additional completions, things like that, correctly. Like for example, let's say, if our parser doesn't take into account the additional spaces that you have in your system, then the autocomplete will be in the wrong location, right? So those are the problems that we have to solve or take care of when writing such a system. Yeah, that's from this slide, and this basically symbolizes that you get a seed of curiosity, and it's your responsibility to grow that, right? So just wanted to leave you with something to think about on your way back.